Hey guys, sorry I'm homesick with Juliana. She didn't feel well this morning. You should be watching this video after you watch the 6-2 video. Some people were still confused, so yesterday I did this in class with period 3 and they found it really helpful, so I wanted to do it for you guys as well and get this video to you. So I'm just going to go through some of the problems and make sure that you guys understand. So there's a chart that you're going to be provided. In the video it said you won't be provided the chart, but you will, that has all of the degrees. So it said like 0 was constant, 1 is linear, 2 is quadratic, 3 is cubic, and then it went 4 quartic, 5 quintic, and beyond that it's just 6th degree, 7th degree, etc. And then we have a monomial, which is one term. And then there's a binomial, 2 terms. And a trinomial, 3 terms, trinomial. And after that, everything is just called a polynomial. So 4 more. Poly, the prefix poly means many. Okay, so what we're going to do is, I actually for some reason always have thought of these terms as little train cars. So if you notice, they're connected by an operation, a plus or a minus sign, addition or subtraction. But I see that I have 2 of those train cars. That would make it the binomial. And then to see what the degree is, I'm looking for the highest degree. So this train car has a degree of 3, and the 6 doesn't even have a variable, so that's a constant. It's a degree of 0. So I know that it's a degree 3, and for the terms, the train cars, it has 2. So in total, so the name would be, not in total, so the name would then be a cubic binomial. So this one is D. Okay, now let's go on to the next one. So here are my train cars. I have 3 of them. So 3 terms is a trinomial. He went to work. Okay, and then degree 3, degree 2, degree 0. So we keep the highest, which is 3. So I have a degree of 3, which is going to be cubic trinomial. So that's C. Okay, and then our next one here, here's my train cars. I have degree 2, 1, 4, and 0. And the highest degree is right here, the 4. So this is a degree 4, which is a quartic, quarter, 4 quarters in $1. So quartic, and then 1, 2, 3, 4 terms. So once you're over 3, it's poly, it's many. So polynomial. Quartic polynomial, so that's A. DCA. Okay, now to find the degree of a monomial, it has to have a variable, first of all. So this number 4 doesn't even have a variable, so that degree is 0. But it's a monomial is like one train car. There's no connectors, there's no addition or subtraction that's happening for these. So what you do is you look to see the degree in total of the train car. So for every variable, you're going to see how many exponents it has. So this is to the power of 1, that's to the power of 2. So in total, I have the degree of 3. Here's my variable n, that's a degree of 8. And then number 7 is a constant, no variable, so it's a degree of 0. Now for a polynomial, we're doing what we did before, where we're checking each train car, and we're going to keep the highest. So this is 2, 1, 0, so the highest degree is 2. we have two train cars here, binomial. But I have a squared b to the first, so that's degree 3, and a cubed b to the fifth would be degree 8. And so I'm going to keep the highest one, so 8 is the highest degree. Okay, for number 10, let's see, we have 1, 3, 0, 2, so the highest degree is 3. Okay, now writing each polynomial in standard form. I'm skipping 11 through 13. But the answer, just so you know, 11 should be 3, 12 should be 3, and 13 should be 4. Now to write in standard form, all that means is to rearrange it so that the highest degree is first. So if I check my degrees here, I have degree 1, 0, and 2. So that degree 2 should have been in the front of this problem. So I'm going to just rewrite it. So it's a positive b squared. And then I'm going to go to degree 1, which is a negative 2b, and then degree 0, which was a positive 5. And then give the leading coefficient. That's just the number in front of the whole entire polynomial. So it's invisible in this case, but the leading coefficient is 1. Okay, let's take a look at the next one. So I have degree of 8 and a degree of 9. So I have to put that negative 8 to the 9th first. Negative 8a to the 9th, sorry. And then it's a positive 9a to the 8th. So I'm just rearranging it. And now I'm looking to see what's in front. What's the leading coefficient? In this case, there is a number there. It's negative 8. So the leading coefficient is negative 8. We could just separate with a semicolon to write that answer. So number 16, I'm looking at all of my degrees. I have 2, 1, 0. Those were in order. But then I have this degree 7 that should have been in the front. So I can rewrite that as s to the 7th, negative s to the 7th, plus 5s squared minus 3s plus 3. And the leading coefficient is the number in the very front, which is kind of missing, so it's a negative 1 is the leading coefficient. Look at another. So degree 1, 2, and 0. So I'm going to write the highest degree first of 2, then it's a positive 2x, and it was a negative 1. And then my leading coefficient is right here, it's 3. Okay, so the next one, g squared plus 5g minus 7, leading coefficient would be 1. 5c to the 4th plus 5c to the 3rd plus 3c squared minus 4. Leading coefficient, 5. Okay, so classify each polynomial according to its degree and number of terms. So this is what we were doing in the beginning. So if I look at each train car, there's 3 train cars and the highest one was 2. So it's a degree of 2, which is quadratic. And the 3 train cars make it a trinomial. And then we have degree 1 and degree 0. So for degree 1, that's linear. And there were 2 train cars, so that's a binomial. Okay, number 22, highest degree is 4. And there are 3 train cars, so that's going to be a quartic. 4, quarter, remember, and 3 is trinomial. Hopefully this is a little bit better for you guys. The answers for 23, 24, and 25, in case you want to try them. 23 would be a quartic polynomial. 24 is a cubic binomial. And 25 is a quartic trinomial.